Hello and welcome back to another episode of Making a Computer in Minecraft. You can see I actually have a skin now. I'm no longer just the Doom guy. I made myself a little computer skin. It was partially stolen from somebody else, partially just my own creation. But yeah, I like it a lot. But yeah, today I think we're going to take a look into giving our computer some real abilities, like addition and subtraction and things like that. We're going to talk about the way that we're going to pull it off, and also maybe even use some outside resources other than Minecraft to help plan stuff. I know I'm in F5 too much, but I'm just so happy with the skin. Look at it. It's so beautiful. But yeah, we're going to start things off by working on a schematic. Is that how you say that? Oh my god, it's just schematic. It's just schematic. I'm so ashamed. Anyways, we're going to work on making a schematic of how we want our full adder to work. And let me explain what a full adder is super quickly. So what we have here is a half adder, which we designed a while ago. I don't remember quite which video it was, but we designed this quite a while ago. And what this can do is this can add 2 single-bit digits together in binary. And that's pretty cool, you know, it's helpful and stuff. But what a full adder is it is a thing which can do the same thing, but it adds what's called a carry. Okay, so you know how in addition you kind of have you have to carry the 1 in order to go up. Or what am I saying? It adds carrying, carrying the 1 in addition. It adds that, meaning we can have this one structure, this one adder. Okay. And we can just place a bunch of them next to each other, and then now it's no longer just one. Now we're no longer just adding 1 bit. We can add 4 bits with just 4 adders next to each other. I hope that made some semblance of sense. I might re-record that. Essentially, we want a design of an adder that we can link a bunch of together. Now, how exactly we're going to do this is a little tricky. But we're going to start off by just thinking about our inputs and our outputs. So first of all, we have our 3 inputs. Yes, 3 inputs for adding 2 digits. I know it's weird. But this is the carry in variable. And essentially, it just functions the exact same as any of these. With the only change being that, also, if all 3 of them are on, then we need to turn on both of these lamps. If that makes any sense. But basically, it's just another single bit of information. And we receive that bit from the previous adder. Or, at the start, for the first bit, for the first adder, it is just set to 0. I really hope this makes sense. I'm not good at explaining things. So I've made our simple logic system here. I will probably throw in a little diorama version of it, a little schematic version of it, in case you're a little confused. I'll throw it in right now. But yeah, so this is just the Minecraft version of that. And hopefully I can use this to give you a slightly better idea of what's really going on here. So, first of all, you can see that it works as intended. 1 plus 0 equals 1. 1 plus 1 equals 2. And 1 plus 1 plus 1 equals 3. Now, what's special about this is, so now we have 2, and how we would hook this up to make it a 2-bit adder is we would, first of all, take our inputs and move them, a little bit further away to make it easier to understand. Actually, I've decided I want to give a better look at this, at how we really wire this. First of all, you'll notice that what we do here is we take the C out, okay, and we run that as the C in to the next operation, okay? And then just what we do is we look at our inputs from this perspective, okay? So these are our 2 inputs. We have 1, 1, and 0, 1. And what we do is we take the bottom bit of each of them and run it over as the A, and then we take the bottom bit of this one and run it over as the B, and then we take the next bit of this digit, of each digit, and add those together. But yeah, you can see here how we've wired them up. We have this bit running over in as the A, and this bit running in as our B. And now, how do we get the output? Well, it's very easy. We're going to use yellow wool as our output. First of all, the sum of this is just the first output. I know the wiring is ugly, but it's okay. We just run the first sum. We run each sum out. A quick summary. Yeah, so we just run each sum out, and then we do the next sum. You know, we're gonna actually run over here so it's easier to read. And then, very important, when we have a C out that doesn't run into another adder, that is also one of our output bits. So we run that one over here as well. This is the ugliest contraption I've ever built. This is not gonna look good on a thumbnail. And now we're done. We have linked everything up, and you can see how this is so much easier than trying to think of the logic for adding 2 bits. We can just combine 2 full adders, and let's see if it works. We have 2 plus 3 equals 5. Bam. And remember, if instead of running this C out over here and down, if we ran that into another adder, we could have added 3 bits together. And then again, we could have added 4, 5, on and on. So if we had a very compact and efficient system, instead of this ugly full adder, if we had a big efficient system, a small efficient system, then we could do 32-bit calculations, which is enormous, and much better than just this. But still, this is what a full adder is and why it is amazing. And now, we're going to work on making one super small. And here is my super efficient full adder. Just take a little look inside, make sure that it works. 1 plus 1 equals 2. And 1 plus 1 plus 1 equals 3. Awesome. And it's perfectly set up to be super easily stackable. So yeah, I'm pretty happy with this design. It fits very rigidly in a small space, which is the most important part about it. You do technically need the space on either side of it because of wiring and things, but overall, this is pretty great. I'm pretty happy. But yeah, that's most of what I got for today. We've done a decent amount of progress. I want to keep this pretty self-contained as something we're working on for the computer, but also just an explanation of how full adders work and how they're helpful. And so that's probably all I'm going to do for today. This is the last video I'm going to be re-recording for a little bit because I am going on vacation. And so yeah, you can probably expect a week and maybe a week and a day of no more uploads, but then I'll be back and we can get back to working on making more systems like this and also implementing them into our computer. But yeah, thank you very much for watching. I hope you have a good day, and bye-bye.